Ever looked at the sand on a beach and wondered what it has to do with, say, the phone in your hand? Well, today we're going to pull back the curtain on one of the most mind-blowing manufacturing journeys on the entire planet. How we turn simple, common sand into the literal brain of all our modern tech. Let's dive in. Yeah, it sounds completely impossible, right? I mean, on one hand, you have simple, everyday sand, and on the other, the absolute peak of human technology. But believe me, there is a direct and frankly amazing link between the two. Okay, so before we get into the how, let's talk about the what. What are we actually making? We're making a CPU, a central processing unit. Think of it as the brain of your computer. The best way to wrap your head around it is to picture a microscopic city, a sprawling, impossibly dense city packed with billions upon billions of tiny electronic switches, we call them transistors, that are constantly flipping on and off to do all the thinking. All right, so every great work of art needs a perfect canvas, right? Well, for a computer chip, that canvas is something called a silicon wafer. And let me tell you, creating this canvas, it's one of the most precise, most demanding manufacturing processes humanity has ever come up with. And this is where we answer that first big question. The whole journey starts with sand. Yep, just plain old sand. More specifically, the silicon dioxide inside it. This stuff is everywhere, and it just so happens to be the fundamental building block for pretty much all modern electronics. Now, this whole first stage is about one thing: absolute perfection. First, they take that raw silicon and purify it to an insane degree. We're talking 99.99999% pure. A single flaw, just one tiny imperfection, and the whole chip is toast. Then they melt this ultra-pure stuff down and grow it into a massive single crystal called an ingot. Why a single crystal? Because electricity needs a perfectly uniform path to travel through. After that, this huge crystal gets sliced into these super thin discs, the wafers, and then they're polished until they are just impossibly perfectly smooth. And when I say smooth, I mean it's hard to even comprehend. Here's a way to think about it. If you blew one of these wafers up to the size of an entire city, the biggest bump on its surface would be less than an inch tall. It is one of the smoothest objects we have ever created, and that level of flawlessness is absolutely critical for the next step. So, okay, we've got our perfect, flawless canvas. Now comes the part that is just truly mind-bending. We are going to print an entire city with all its buildings and roads right onto the surface of that tiny wafer. And the scale we're talking about here is just staggering. A single high-end chip today can have over 50 billion transistors. Just let that sink in for a second. On a little piece of silicon, smaller than your thumbnail, you have more individual components than there are people on Earth. It's just wild. You know, it's one thing to throw around a number like 50 billion, but trying to picture how small these things are is something else entirely. A single transistor is maybe 10 nanometers wide. For comparison, a common virus is about 120 nanometers. So we're building switches that are more than 10 times smaller than a virus. We are literally engineering things on a scale smaller than biology. So how in the world is that even possible? Well, the magic behind it all is a process called photolithography. The easiest way to think of it is like a ridiculously advanced 3D printer. But instead of squirting out plastic, it uses beams of light to etch patterns layer by microscopic layer. And the machines that do this, oh man, they are some of the most complex and expensive pieces of equipment ever made. We're talking hundreds of millions of dollars for a single machine. And this whole thing works as a loop that just repeats over and over and over. First, you deposit a new layer of material onto the wafer. Then you coat it with a special light-sensitive chemical. After that, you expose it. You basically shine a blueprint of the circuit onto it with extreme ultraviolet light. Then you etch it, which means you wash away all the bits that got hit by the light, leaving the pattern behind. And then you do it again and again. Hundreds, sometimes thousands of times, slowly building up this incredibly complex 3D city of transistors and all the little copper roads that connect everything together. Okay, so after all those hundreds of layers are finally done, you don't have just one CPU. What you have is this big, beautiful wafer that's now covered in hundreds of potential CPUs. The last part of the journey is all about sorting the good ones from the bad ones and then packaging them up for the real world. See, even inside the cleanest rooms on Earth, and these places are way cleaner than an operating room, you can't avoid tiny defects. A single speck of dust can ruin a chip. So a super precise robotic probe has to come down and test every single one of those hundreds of chips on the wafer. It pokes each one, runs a bunch of electronic tests, and basically makes a map of which ones are perfect and which ones are duds. This whole process has a name. It's called yield. And that number, the percentage of working chips you get from a wafer, is one of the most important stats in the entire industry. If you get a good yield, maybe 85% of the chips work, but that means 15% are completely useless and have to be tossed out. That built-in loss is a huge, huge reason why these chips can be so expensive. So once we know which chips are good, a diamond-tipped saw comes in and literally dices the wafer up into hundreds of individual little squares. At this point, they're called dies. Each working die then gets placed into its protective package. That's the thing you actually see. A metal lid, called a heat spreader, gets slapped on top to help it stay cool. And then, believe it or not, it goes through one more round of super intense testing, just to make absolutely sure it's ready to go. And that's it. That's the journey. You start with sand, you purify it, you polish it to perfection, you print a microscopic city on it, and a simple, dull piece of silicon gets completely transformed into one of the most complex things human beings have ever made. It's really incredible. So yeah, going from a handful of sand to a city of 50 billion transistors, it really is a modern miracle. And as this technology just keeps getting smaller and more powerful, you have to wonder, what's next? What kind of world are we going to build when these tiny cities have not just billions, but trillions of transistors?